Now that we've finished our work with some of our basic polygons and the area of those polygons, such as rectangles, parallelograms, triangles, trapezoids, and kites, and we've done some applications of them, we're going to move on to the areas of regular polygons, and this would be something that I believe will be new to everyone. So let's take a look at how this works. On the page, you're going to see a circle, and inside the circle is inscribed a regular pentagon. Right? A regular pentagon is going to have 5 equal sides and 5 equal angles. But in terms of the area, we need to define one other little characteristic here, and the name of it is called the apothem. Okay? Apothem, kind of a weird sounding word here, probably not one that you've heard before, but when we say apothem, did you say opossum? No, I said apothem, not opossum. Okay? Apothem, not opossum. Okay? Sorry for that random interjection there, but I thought that was funny. So an apothem is the segment, and we'll name it with a lowercase a, so that's what this a is here for, but a segment from the center of the polygon perpendicular to the side of the polygon. Okay, so you can see where the apothem is right here. We say it's perpendicular to the side, so this segment right here, and the reason there's a circle here is it kind of helps us see that this is the center of that polygon, it's the center of the circle also, but this is a right angle right here. And you could do it a apothem to any of these sides, but just one is drawn in for reference here. Okay, so let's figure out what the area formula is for this regular pentagon, or any regular polygon really is our eventual goal. So look at this triangle right here. And when I say right here, I mean this triangle here. We know that the area of a triangle is base times height divided by 2. Base times height divided by 2. And in this particular situation, the base of our triangle is one of the sides of the polygon. So we're going to label it with S. So base, and the height of our triangle right there is the apothem, not opossum, apothem. Okay, so A, right here, the apothem, so base times height divided by 2. That's the area of that isosceles triangle in terms of A and S. Okay, so base times height divided by 2, S times A divided by 2. Well, what is the area of the entire pentagon there that we've outlined in green? Well, how many of these little blue triangles would there be if we sketched them all out? That's right, there would be 5. I know I just heard you guys say 5. So really the area of that whole pentagon is 5 times, now I'm just going to put the A first here, so A times S divided by 2. It's 5 of those triangles. And so the grand total area would be, if you work this out, would be 5 times A times S divided by 2. Okay, because there's 5 of those triangles, so that's how it would work out. Now you could actually, state this as a decimal, which should be 2.5 times A times S. But we're going to leave that 5 times A times S divided by 2. So let's see if we can figure that out for the shape down here. Count the number of sides here. Okay, that would be a hexagon. So hexagon we can also break up into all these triangles, and again we're just going to look at the area of one of those triangles. So the base of this triangle is the side length of the hexagon. So one side length of the hexagon, so we're going to use the letter S again to represent the side length of the hexagon. And the height of this triangle right here is the apothem of the hexagon. So once again, we have base times height divided by 2 for the area of this triangle right here. How many triangles are there if we pieced them all together inside of the hexagon? That's right, there's 6 of them. So 6 times SA divided by 2. And we're just going to simplify that a little bit. Again, we're going to put the A before the S, multiply that 6. So this is really 6 times A times S divided by 2. And you might look at that and say, well, this can be simplified to 3 times A times S, and you would be correct, but we're just going to leave it like this for right now so we can notice some patterns. Let's do that one more time. We've got an octagon here, 8 sides. Once again, we're going to take a look at the isosceles triangle right here. The base of it is the side length of that octagon, and the height of that triangle is the apothem. Notice that there are 8 triangles all the way around here now that would fill up the entire area of our octagon. So 8 of those triangles, 8 times A times S divided by 2, or 8 AS divided by 2. Okay, so now let's just see if we can generalize this to an overall formula for any regular polygon. We looked at a pentagon, a hexagon, and an octagon, but you probably are noticing that there's some patterns here that could be applied to any regular polygon. So let's just start to fill out our table here. So we had a pentagon, which was 5 times A times S divided by 2. That was the area of the pentagon. We had a hexagon, which was 6 times A times S divided by 2. And we had an octagon that was 8 times A times S divided by 2. All right, well, how is the number of sides related to the formula? Well, that 5 appears right here. 6 sides, that 6 is right here. 8 sides, that 8 is right here. Everything else stays the same. We still have the A times S divided by 2. So, of course, then a 7-sided polygon, and a regular polygon would be a heptagon. So that would be 7 AS divided by 2. A nonagon, 9 AS divided by 2. Decagon, 10 AS divided by 2. Okay, if we move up to a dodecagon, 12 AS divided by 2. So what is the formula? If we have n sides, in other words, just some generic shape where n is the number of sides, I shouldn't say a generic shape, but a generic regular polygon with n number of sides, hopefully you're noticing that the number of sides goes right into that first spot. So n times A times S divided by 2 would be the general formula for the area of a regular polygon. Now in the book, it just reorders these letters a little bit into A times S times N divided by 2, where A is the apothem length, S is a side length, and N is the number of sides. So now we will use that formula right here for the area of a regular polygon.